Welcome back to my channel. In this video tutorial, we are going to focus on De Morgan's law relating to logic gates. So what says the De Morgan's law? De Morgan's law states that the complement of the product is replaced with the sum of the complement, while the complement of the sum is replaced with the product of the complement. So what does that mean in that sense? Let's interpret that. It means if you have the negation, typically the NOT gate of the product of some inputs A, B, C, then all the way to N, for instance, this can be replaced by the sum of the complement, that is A bar plus B bar plus C bar, then all the way to N bar. And for the second interpretation, it says that the complement of the sum is replaced with the product of the complement, which implies that if I have the complement of some inputs to be adding each other all the way to infinity, for instance, then this can be replaced with the product of the complement, A bar times B bar times C bar, then all the way to N bar. So that's just the basic idea behind De Morgan's law. But there are some properties that you need to be familiar with, and I would love to share that with you. The first one is you need to know that an input plus 1 will result in 1, regardless of whatever the input is. Okay, it will always result in 1. And an input plus the input will remain the input. Keep that in mind. It's something you want to work with. Now, what about an input times 1? What would that become? Will it be 1? It turns out that it won't be 1. It will be back the input. Okay, since logical circuit only accepts 2 inputs, and which is no more than 0 and 1, that is true or false, then you can always use these inputs to always you can use them as a reference to your answers. I don't know, maybe you get what I'm trying to say makes sense. Like for instance, if you want to use those inputs as a reference to how this answer is gotten, you can assume A is 1 and add it to 1. 2 statement plus 2 statement will result in 2 statements. But what if A is 0? 4 statement plus a 2 statement will eventually result in 2 statements according to the OR gate properties. You understand? You can always use this method, this process, to confirm if your answer is right or not. So let's move on. So I'm just going to get rid of that. Perfect. So what if an input is adding 0? That is, a certain input plus a 4 statement. In this case, you need to keep in mind that it's going to result back in that input. It's going to result back to A. And at the same time, if A is multiplying 0, in this case, it's going to be 0, because anything times 0 is going to be 0, like the way I usually used to explain problems involving logic gates or logical operators. I usually used to use object form so that you guys can get what I'm trying to say. It makes sense. So the next thing you need to be familiar with is when an input is pairing itself with a complement, both on the AND side and on the OR side. So let's begin with the AND side. What is the value of A times A bar? What will this result to? Then you keep in mind this is going to be equals to 0. Now I'm going to show you why it's going to be 0. Assuming A is a 2 statement. Okay, that's going to be 1. Definitely A bar will become a 4 statement, 0. Tell me, is 1 times 0 indeed 1? Absolutely not. 1 times 0 is equals to 0. Now let's consider the other way around. Let's assume A is equals to 0. A is a 4 statement. Then definitely A bar will result in a 2 statement, 1. Tell me, is 0 times 1 is it equals to 1? Absolutely not. 0 times 1 is indeed 0. So that's just how it works. When the complement of an input is multiplying itself, typically the input, then the result is going to be 0 in this case. Hopefully you got that. Now the next one is when an input is adding its complement. What would this become in this case? So in this case, the result to be is going to be 1. The result is going to be 1. You can always show that with the way I just did recently. You will observe that regardless, the answer will always be equals to 1. Now, what if an input is multiplying 1? What will be the result in this case? If an input is multiplying 1, the result will always be equals to A. So the result will always be equals to A, regardless. So if A is 0, 0 times 1 will become 0. And if A is 1, 1 times 1 will become 1. The result selected end up being A. So that's just what you need to know. Well, I think I almost forget. There's one more thing you need to know, which is very, very important. The complement of a complement result back to the input. Please, this thing is mostly often used in problems in De Morgan's theorem or De Morgan's law, excuse me, of logic gates. So keep that in mind. The complement of the input is equals to that input. So these are the basic things you need to know about De Morgan's theorem. Before I end this video, I would like to go over some examples in order to apply all these properties in order for you to see the beauty behind De Morgan's law. So first, how can we simplify this? A plus B plus C bar, and all having a bar. So if you could recall, whenever you want to solve problems involving De Morgan's law, let me share this with you first. You start from the upper part. You start from outside. You don't start from inside, meaning that you have to start from this upper bar. So how can we simplify this upper bar? We can say that the upper bar is relating an input to be adding another pairs of inputs. And according to De Morgan's theorem, when we are having the complement of a sum, then we can replace that with a complement or with the product of the complement. So that will become A bar then multiplied by B plus C bar, then all with a bar. So finally, we can proceed forward. We can see that B plus C is having a bar initially, and again another bar as eventually comes. And we said that an input having a bar, again having a bar, will result back to that input, and this will become A bar then multiplied by B plus C. So that should be your final answer. However, you can simplify by just expanding the bracket according to the distribution property. So that will be A bar multiplied by B plus A bar multiplied by C. And this is the final answer. Hopefully you grabbed that. Let's consider some more problems for easy understanding. So if you haven't subscribed to my channel, please do subscribe to my channel. And also, if you are finding this content interesting, kindly give the video a thumbs up to show love, so YouTube can recommend the video to many viewers out there. So how can we simplify A times in a bracket of A plus C all to the power of bar? So according to De Morgan's theorem, the complement of product can be replaced with the sum of the complement. So this can be replaced with A bar then plus A plus C bar. Now we can simplify this again, since we are having the complement of the sum. According to De Morgan's again, the complement of the sum can be replaced with the complement of the product, and that will become A bar plus A bar multiplied by C bar. Okay, I will replace the sum with the complement. So eventually this will become A bar plus A bar multiplied by C bar. Now at this point, I can just factorize A bar out. So I can have A bar outside, then 1 plus C bar. Now it turns out that regardless of what C is going to be, adding 1 to it will result in 1. I think we discussed that earlier while discussing about the basic properties that you need to be familiar with when dealing with problems involving De Morgan's law. But I would like to disclose with you, okay, for a true disclosure. Let's assume C is 0, that is a false statement, that is a no output, a false output. Then C bar will be equals to 1. And at the same time, which is the other case around, if C is equals to 1, then C bar will be equals to 0. So let's substitute the value of C bar in the two cases and see if the result will not be 1. So for the first one, 1 plus when c bar is 1, we can say that is 1. And 1 plus 1 is indeed equals to 1. Now what if when c bar is equals to 0? In this case, it's going to be 1 plus 0, and finally it will still be 1. So therefore, 1 plus a certain input, even if the input is a not input, that is a negation, is still going to result in 1. So please, it's something you want to keep in mind. So therefore, our answer is just going to be finally a bar. So the final answer to this problem is going to be a bar. And that's it. You can see these are the basic way to simplify problems involving De Morgan's law. So here's an exercise for you for practice problem. Hopefully you find this helpful. If you haven't subscribed, like I said earlier, please do subscribe to my channel. Feel free to comment your solution in the comment section below for review. I'm going to respond to you if your answer is right or not. Thanks for watching. See you guys in the next video. Bye for now.